interesting example here from a bus journey from Leeds to London, but we don't care about what the journey is. We do care that it's normally distributed with mean of 220 and standard deviation of 8, so the variance is 8 squared. So our first question, calculate the probability of a bus taking longer than 235 minutes. So the probability that x is greater than 235. For 2 marks, don't do more work than you need to here. Go straight to your calculator. Statistics, normal CD, so we want the probability of everything greater than 235. So the lower value is 235, upper value, put in any very high, 10 to the power 10, everyone chooses a high number just to represent infinity. Sigma is 8 and mu, our mean, is 220, and let the calculator do the work for that one. The next part, the bus companies suspect that the mean bus time has changed. So we don't know if it's higher or lower, but we know that it's changed, so it will be a two-tailed test. So our null hypothesis, the mean is still 220, as it was in the start of the question. And H1, our alternate hypothesis, the mean time has changed, so the mean is not 220. An easy 1 mark there for a two-tailed test. For the next 3 marks, they need to give us an example. So we've got an example of a sample of 10 bus journeys, and they had a mean time of 230. So n equals 10, and the mean of those, the x bar, that was our sample mean, is 230. We want to test if this is strange. So this is higher than our mean of 220. So we're going to check the probability that x is greater than 230. Remember, for our sample distribution, this is normally distributed with mean 220 and standard variance 8 squared over the sample size of 10. So make sure when you put this one in, put your standard deviation as 8 over the square root of 10. So back to normal CD again. A lower value of 230. Upper value, any high number to represent infinity. Sigma, the square root of 8 over the 8 over the square root of 10. As a decimal, I think that's 2.5298, so I'll put that in. You can just write it in as 8 over root 10, and our mu is still 220. So that probability is 3.86 times 10 to the minus 5. So the easiest thing to do now is to draw it on a graph and see what we've got. This was a two-tailed test with a 1% significance level. So we have 2 tails and 1% split between both of those tails. So 99% of the data falls in the central acceptance region, and we've got 0.5% falling at each side. So as a decimal, we've got 0.005 on one side and 0.995 at the other side. Everything in the middle is our acceptance region for accept H0, and then either tail, if this value falls in either of those 2 tails, then we'd reject H0. So if I plot on R value for the probability that x is greater than 230, this is 0.0000386. That is obviously less than 0.005, 0.5%, and that falls in our rejection region, so reject H0, and conclude that the mean has changed. Now, an even more interesting example about fuel consumption. So we have a normal distribution, which is what we like, mean of 34.6, standard deviation of 3.38. So we have a refinement made to the engine, which is thought to improve performance without affecting fuel economy. Quite a pointless sentence, but let's see what we've got to do with that. So the fuel consumption of 25 cars, so our N is 25, had a mean fuel consumption of 32.9. So our sample mean, X bar, 32.9. We have a 1% level of significance hypothesis test. that the consumption has decreased after the engine environment. So now we want a one-tailed test. So to start with, we have our H0 will be the mean is the same. The mean has stayed at 34.6. And our H1, the mean has decreased. So the mean is less than 34.6. And this is our one-tailed test. From our example that we have n is 25 and x bar is 32.9. So we want to test if this is strange for our sample to have a mean of 32.9. That was less than the 34.6. So we're going to check the probability that x is less than 32.9. So working with our sample distribution now, we have a normal distribution of a mean of 34.6, same, and the variance is the 3.38 squared over the sample size of 25. So when you put this into your standard deviation, you'll put the standard deviation as 3.38 over the square root of 25. So to calculate your probability that x is less than 32.9, we'll go straight to your calculator. Normal CD, because we want that cumulative probability. The lower value, any number to represent minus infinity. Upper value of 32.9. Sigma, or standard deviation, 3.38 divided by the square root of 25 comes out about 0.676, and our mu we know is 34.6. So with this value, then we want to compare it to our 1% significance level. So I'll just draw this out because it makes it easier to see what's happening. So in a 1% one-tail test, so we only have one tail in this one with 1%, and 99% of the data is our acceptance region. So we'd accept H0 if it falls in there, and reject H0 if it falls in this small 1% tail at the end. So that value there will be 0.01 as a decimal. So if I just draw on this probability that x is less than 32.9, or 0.005955, we can see that that is in the rejection region. So since that is less than 0.01, we will reject our H0 and conclude that the mean has decreased and the mean is less than 34.6. So third and final example, I won't bore you with these because I feel like you can do hypothesis tests. So we have a mean of 170, a standard deviation of 6. Our first example that they've given us, the heights of 4 male students from this college are measured and the sample mean was 180. So we have n equals 4 and x bar equals 180. So the sample distribution for this is normally distributed with mean 170 as normal and standard, variance 6 squared over 4. So when we put our standard deviation into this later, we'll use 6 over the square root of 4. So always remember to divide by the sample size. We want a 5% level of significance test whether the mean is greater than 170. So our H0 is that the mean is equal to 170, and our H1, the mean mu is greater than 170. So we want to test this sample of 4 students when we had a sample mean of 180. So we'll test if this is strange. 180 is greater than the mean that we'd expect of 170. So we're testing the probability that x is greater than 180. For this, I'd go straight to your calculator, CD again for the cumulative probabilities, and put in the lower, upper, mu and sigma. So the lower value is 180. I say 180, I put it into the calculator and I write 170. You know what I mean. The upper value, put any number that represents infinity. Sigma is 3, and that was 6 divided by the square root of 4. And our mu is 170. So if you put all of these values in to calculate the probability that x is greater than 180, we get 0.000429. from that point, we can compare this value to 5%, and that's fine to do so there. I'll just draw it out just so you can see what's happening, but you don't need to do this in the exam. So because we have a one-tailed test, we just have all of that 5% in one tail, and 95% of the data is in the acceptance region, where we'd expect all of these values to fall. So if it falls above 0.05, then we'd accept H0. If it's below, we reject H0. Our probability, if I just plot that one on there, was definitely below 5%. So you can just write in the exam that is less than 0.05, and therefore we will reject H0 and conclude that you can then just reword H1, the mean is greater than 170.